Hello, and welcome to this edition of Notes with Mr. Waz. Today's notes are on section 2.5. Now that I'm done being a NPR radio announcer, here we go. So, we're going to do two sets of notes in one day because really, if you looked on Thursday is just an additional day of what we're doing with this already. So I'm just going to include all the notes in one, and you won't have any extra homework on Thursday. You can catch up on some things if you need to in class, get some of your Delta math things done, any of that. So this is your notes for Wednesday night, and it will carry you into Thursday night as well. So we're just going to have one more set of notes for this week because Friday, we're going to get your review. So here we go with 2.5. So 2.5 notes are what we call literal equations, probably one of the most misused and overused words. And people always say literally, but that's a whole nother thing that I'll talk about some other time. So for literal equations, we're looking to solve things with multiple variables. And the key with these is your answers will have multiple variables. So when we're looking at this, you're not going to get x equals 7. We're not looking to solve for one single thing here. So when we're looking at some examples here, the first one I'm going to do is some y equals, or we're going to solve for y. So I'm going to give you 2x plus y equals 7. And a lot of these will either say solve for y. You'll see something like y in front with a colon. But I'm solving this for y. So what I'm going to do with the y, this is my method. I suggested it just as the visual to help me with it. That means that variable is never going to move unless it's in a denominator. So never move the variable you are solving for unless it is in a denominator. Another good story that used to be my wrestling name, The Denominator, and I changed it up a little bit. I'll talk later about that. Probably not on here, but some other time in class, ask me about it. So 2x plus y equals 7. When we're looking to solve for y, I'm not going to move the y. That's what I'm solving for. So all the steps are really the same if I'm solving. There's no parentheses, and even here we're not going to distribute parentheses. So I'm going to add that into here as another note. Okay, never distribute out into your parentheses. That's the only step that's really different. But other than that, it's not. I don't have like terms here, so I can't combine them. I want to get y by itself. So in order to get y by itself, I need to move this term, 2x. Okay, you don't always have to underline it. To move a 2x, I need to do the opposite of what it is. The opposite of a positive 2x is a minus 2x. So I subtract 2x from both sides. Now, on the left side, all I'm left with is y, because here 2x minus 2x cancels. On the right side, I'm left with 7 minus 2x, or negative 2x plus 7. Now, I'm going to get us in the habit of writing it that way. Y, something later on down the line called slope-intercept form. Y equals mx plus b. Maybe you remember some of it from last year where m is our slope, b is our y-intercept. If you wrote y equals 7 minus 2x on a test right now, I'd take that too. Now, how do you know that's it? Like, Mr. Waz, what'd you do? Well, negative 2x and 7 are not like terms. So what's negative 2x plus 7? It is literally negative 2x plus 7. That's it. We're done. This or this is our answer. So you could see answers are going to have multiple variables in there. I'm not getting x equals 2. Literal equations are really just, or at least to me, I think of it as you're rearranging the equation. You're solving for another variable. So the first night, or the first day of our homework that we're really working on these, you're going to be solving for just y's. So I'm going to give another example of this. Let's say I have negative 3x minus 5y equals 15. And I'm solving, sometimes you'll just see that like semicolon y. So I'm solving for y. Now, little different here because I have a negative 5 in front, but it's really the same steps I have for solving. I want to get rid of any other things not with this term. The term is negative 5y. So to get rid of a negative 3x, I do the opposite function, which is positive 3x. So I'm going to write it here again with the x first. So I have 3x. 15 is positive, so I put plus 15. I don't have y all by itself yet, so I'm looking and saying, all right, how is negative 5 and y attached? Well, it's attached by multiplication, so I need to divide by negative 5. Now, I just need to divide everything by negative 5. So I'm left with y equals, here you could put the negative in any spot. 3 divided by 5 is just that. It doesn't simplify as a fraction, so it's negative 3/5 x. 15 divided by 5 is negative 3. There's our answer. So the steps are no different than what we've been doing. It's just the fact that we get answers that have variables and really all the other numbers still in there in some form. Okay, let's look at one more solving for y. Let's say we have x equals 2y plus 13. So in this case, the y is over here. It's not in a denominator, so I'm not going to move it. So this is what I'm trying to solve for. So to get the y by itself, I first need to move over anything that's not in the y term. So 2y is the term, so I subtract 13. Well, what is x minus 13? X minus 13, literally, because there's nothing else to combine there. They're not like terms. And that equals 2y. Y still not by itself. So I want to get y all by itself. Well, how are they attached? It's attached by multiplication, so I need to divide, but I'm just going to divide each thing individually. Now, you could leave this as x over 2 minus 13 halves equals y. That's fine. Some people are like, well, that's 1x over 2. They like to see it as 1/2 x, so the fraction's in front, minus 13 halves, and I just flip the y. Any of those would be okay. More than okay. Absolutely correct. Okay. All right. Now we're going to look at a couple where we have, I'm going to do d equals rt. So a lot of these are real equations. This is distance equals rate times time, and I want to solve for r. So this is not a j, this is a semicolon. So if I'm solving for r, I look and say, okay, well, t is on the same side of it. How are r and t attached? That's a big question. You may want to jot down somewhere on there. Like, how are they attached or how are they connected? They're connected by multiplying. The opposite of multiplying is dividing. So I divide both sides by t. So I have d over t equals r. If you want to flip the whole thing, you could do r equals d over t. For that one, that's it. So you did one thing to solve it. You have all the letters that are still in there. That's the part that tends to throw people off the most. Okay. Let's look at one with a fraction in there. K equals 1/2 m times v squared, and we are going to solve for m. So this is about as tricky as they get. This is, I think it's kinetic energy. Yep, K is kinetic energy of an object, m is its mass, and v is its velocity. So if I want to solve for m, I need to get rid of everything else over here. So I'm going to do this one part at a time. So if I look and say, well, 1/2 is attached by multiplication, I'm going to divide by 1/2. That's one way to think of it. Or what we've talked about with fractions is it's like a denominator. I have a 2 in a denominator. I would think of it more like this. I'm going to multiply both sides by 2. So I get 2k equals m times v squared. People here will think, oh man, v squared, I don't know how to do it. We haven't done stuff with squared. No, you're good. Don't overthink it here. It's just the question, I want to get m by itself. How are m and v squared attached? Well, we don't write the dot, but there's a little dot in there. We're attached by multiplication. So to solve for it, I am going to divide both sides by that whole variable and exponent of v squared. So over here, what's 2k divided by v squared? Exactly what you said. 2k divided by v squared. So again, if I want to flip it, I could write the m first equals 2k over v squared. And that's it. We don't have anything else to do. Okay? All right. So you could see we just have a couple different ideas there of some of them have y, some don't. It doesn't really matter. I shouldn't even say ideas, types of problems. It's still all just solving equations. That's it. We're still just solving equations. It's just a matter of now our answers aren't going to look like x equals 7 or infinitely many solutions or no solution. These all have solutions. I'm rearranging the equations to look at them. So the key thing is you're going to have answers. They're going to have multiple variables, and that's okay. Okay. You never want to move the variable you're solving for. You're going to leave that right where it is. Everything else, you figure out, how do I get it to the other side? Positive 13, you subtract 13. A 2 attached by multiplication, you divide by 2. Okay, so we'll get lots of practice with this over the next couple days. We're going to split it into 2 days, where the first day on Thursday, you're really just going to be working on these problems where you're solving for y. Then the next day, we'll work on ones that are more like the bottom ones where you could solve for any letter. Okay, so that saves you a day of notes. We kind of are doing 2 sets of notes here in one, since it's all really the same thing. We're just going to add some extra practice with it. So keep up the good work. Way to watch the video. Write down the notes. Come with questions if you have them tomorrow, and we'll go over whatever you may have. Have a great day, and I need like a catch line at the end. I'll work on that. Talk to you later.